Hi, I'm Adrian Bowles. Early in my career, I taught theoretical computer science. I taught software engineering and artificial intelligence in computer science departments. But more recently, I've taught topics like electronic commerce, analytics-based marketing, and advanced decision support in business schools. I've moved from a focus on technology to a focus on problem solving with technology, which is the reason Watson is important to my work. What gets me so excited about Watson is that you don't need to know anything about computer science to see the potential. But if you do understand the underlying science and engineering, you'll see even more opportunities for Watson to fundamentally change the way we solve complex problems. That's a huge and for now a unique opportunity for IBM. Of course, there's a class of big data problems that is well suited to conventional computing, where if you have faster processors or more processors, you get faster results and better results. That's kind of been the history of computing. If we could throw more processing power at something, we get the results sooner, or we get better results because we could consider more pieces of data. But there's another class of problems where faster alone is insufficient. We're talking about things that are very complex, perhaps where there's uncertainty, and certainly where there's high risk. And that's an area that, although we've attacked it in some ways, and we've tried to partition problems, and we've tried to do things like rule-based systems, we've never really been able to add value in the computing other than speed. And what we want to get to in the future, certainly with those of us that are concerned with improving the quality of life using technology, is going beyond speed and getting into really delivering value from insights. This is the type of problem we routinely assign to highly skilled, highly trained, or highly educated professionals, from doctors to financial analysts, people who deal with policy decisions. When someone has to go beyond simple rules and case studies to consider context to make decisions with real consequences, we routinely trust the experts. And almost inevitably, within a class of problems, the experts still make too many mistakes. They still need help pushing the edge of the performance envelope. And that's where Watson shines as a decision support tool, not as a replacement for judgment, but as a tool that can provide this context, that can provide analysis that informs a decision by the expert. There's still quite a bit of confusion in the market as to what constitutes a Watson versus the underlying technologies that comprise Watson. So if we start with the archetype, the Jeopardy champion configuration, that was a standalone or non-network cluster off-the-shelf hardware components that was running a natural language processing front end that fed a deep QA or question answering system that referenced a huge in-memory repository of data, generated multiple evidence-based hypotheses, and finally evaluated and selected the highest probability answer, or Jeopardy question, while also returning the alternatives that it had come up with their relative likelihoods. That Watson had over 100 subsystems, but those four characteristics, natural language front end, deep QA, fast access to vast stores of relevant domain data or knowledge, and evidence-based probabilistic hypotheses testing. That's a mouthful, but think about it for a minute. It's evidence-based. There's a way to justify what you've come up with. Probabilistic in that it doesn't try to determine one and only one right answer. Hypothesis testing. So it's actually testing various hypotheses in parallel. Those are the essence of Watson. You may find pieces of Watson embedded in other solutions, but without all of them, I wouldn't consider it to be a Watson. So if you take those four attributes together, you get Watson. And to me, it's exciting, and it's an exciting time to be looking at technology because it really is providing a fundamental shift in the types of problem we can attack intelligently using computers. In the first generation, the way I think about things, we had computers for computation. We had data processing. We had machines that would take alphanumeric input, do some computation, provide reports. It was trying to automate things that largely had been done before, or if they hadn't been done before, it was just because of the volume of data. So we've always had an issue of what we think of as big data, where it was something that stretched the capability. And if you don't have a computer, big data doesn't have to be very big. But once you started to get into mainframes, micros, any level of computing is a way to automate the processing of this data. But the next generation, we started to look at computing as a way of going beyond just computation to incorporating communication. So we start to think about computers as a way of helping us to improve the collective intelligence, if you will, of an organization. But still, we're taking the individual contributions and putting them together using computing technology or information technology as a way to do that. Where Watson goes beyond those fundamentals in those first couple of waves is that it really is providing what we would think of as cognition or a cognitive system. And although we've had things in the past that were labeled cognitive systems, and I've worked on expert systems ranging from things like an airline battle management system that was fundamentally rule-based, to insurance processing systems, to some fairly sophisticated systems that look for drug interaction when you go to your pharmacist. It's not just a person that's looking at that, but there are systems that can look at chemical interactions based on the compounds that are used in the drugs. Those are all important, but they're not thinking. They're not going through a process that I would think of or consider to be cognition. Where Watson is really different and exciting is that by generating hypotheses and testing hypotheses and working as a partner in their current configuration rather than as a standalone Jeopardy player, but working as a partner with a trained practitioner in an area like cancer diagnosis, Watson can help even the most experienced, even the most proficient expert perform at a higher level because it can automate that data gathering. It can act as a partner, if you will, to trade off on hypotheses. But because it's evidence-based and because it's probabilistic rather than deterministic, it is the most intelligent system, if you will, that we've ever seen. I've been at this for a very long time, and I can tell you that there is nothing that I've seen in terms of smarter systems gets me as excited as Watson.